Hi again. I've had a great time this weekend playing loads of retro games at the RMC Retro Computer Museum. Revisiting classics on the computers and consoles of my youth, proving that games really did used to be harder in the old days, and getting to see some real rarities. A fantastic way to cheer up a rainy Saturday morning in January, and the kids loved seeing the video games that Mum and Dad played when we were their age. A big thank you to Neil and the team for their hospitality, and I thoroughly recommend both the RMC YouTube channel and a visit to the museum itself the next time that you're near to the Cotswolds. From an AI perspective, it's interesting how many cutting-edge AI developments involve games in general and video games in particular. Trying to build computers to beat chess grandmasters was the cutting edge of AI in the 90s. Natural language processing had its show business moment when IBM's Watson won US TV game show Jeopardy, when DeepMind's AlphaGo and later AlphaZero achieved supremacy in Go. We've seen video gaming used to test AI systems with everything from old 8-bit Atari games of the type I was playing this morning to multiplayer online battle arena esports like Dota 2 also being used in AI. And why this focus on gaming? Well, one simple answer is that games have a definite objective: to win. In board games like chess, it's possible to assign values to pieces and positions and evaluate which moves are likely to maximise strength of the AI player's position relative to their opponent. Video games award scores and have objectives to be followed, so they provide a useful feedback mechanism to indicate progress, which has no easy equivalent in the real world. Games represent the perfect training environment. Video games in particular often have some delay between an action and the reward in points, completing a level or winning a boss fight. This is very useful in training AIs to learn to plan ahead, which can then have direct benefits when transposed to real-world use cases. Video games or virtual environments can also be a great source of data that will be difficult or expensive to acquire by any other means. In its AI Day presentations, Tesla showed off its use of virtual environments as a source of training data for self-driving, in an environment which would seem instantly familiar to anyone who's played open-world games with a driving element like the Grand Theft Auto series or Forza Horizon gaming series. The benefit of these virtual environments is that they can auto-label all of the geometry. No longer does video footage have to be painstakingly labelled to identify curbs, bollards, buildings, traffic lights, etc. The virtual environment can render both game-like virtual video feeds to simulate what the car's camera might see, and they can also present fully labelled versions of the environment to train the self-driving AI to recognise these elements within the environment from those video feeds alone. Just as play is the way in which developing minds learn about the world, video games and virtual environments can teach AIs about the world that they are going to be encountering. They can be a great source of synthetic data. And there can be some real advantages from a legal perspective to generating synthetic data, whether that's using games or otherwise. The first and most obvious benefit to synthetic data sets is that they can avoid data protection complications that would arise if using real-world data, which potentially includes personal data. Any data set that starts out as personal data can only be processed where there's a lawful basis and the purpose of the processing was made transparent to the data subjects. Therefore, even processing a data set to anonymise it or to pseudonymise it can be problematic. We've also seen a heightened level of awareness of the copyright implications of the use of data scraped from online sources for AI training, particularly in the context of text-to-image models. There are interesting questions to consider in relation to whether tweaking the weights and values in an AI model could really constitute copying in the context of using images for AI training. However, those questions can be avoided altogether by using synthetic data that you generate for yourself and own all rights in, if that's a realistic alternative method of training. So much for the benefits of synthetic data, but some care needs to be taken as well. The first and most obvious point is that the synthetic data needs to cover all of the scenarios that the AI being trained is likely to encounter in use. If you're training an AI by playing games, and it will only ever be used to play games, then the synthetic data will cover the likely range of inputs the system might see in use. However, if you're generating synthetic data to train a business system to process, let's say, insurance claims, you need to ensure that the synthetic data sets that you're generating and using for training match up statistically with the real world data that the system would encounter when deployed into production. Similarly, if you're training a self-driving system in a game like 3D World, it needs to be realistic and detailed enough to match up with the real world that the car will be driving in. And it needs to provide for a wide range of encounters that cover all of the scenarios, both good driving and bad, that a vehicle might see in the real world. Now, all of this needs to be recorded and validated. Existing safety requirements and forthcoming AI-focused laws will require AI operators to do so. From an AI regulatory perspective, Article 11 and Annex 4 to the EU's forthcoming AI Act will require the provenance of AI training data to be recorded amongst many other aspects of the design, architecture and training of the AI model. But back to our day at the RMC Retro Museum. After a fantastic morning of gaming, the weather had brightened up and we all thought we'd had enough screen time for the day. Since we're in the Cotswolds, what could be better than a lunch in a delightful tea room and then a good walk? The best of both worlds, video games in the morning and real world adventures in the afternoon. Even there we see a lesson for AI. The answer to the data sources problem might be to use synthetic data for things it's best at, but augment it with datasets gathered from real use cases too. That way, AI training gets the best of both worlds too.